Ever thought your boring set squares could turn into a world of quadrilaterals? Let's reveal the math magic. First, let me explain you the two types of set squares which we have in our geometry box. So this is one of the set square which we have in our geometry box, right? You can see there is a right angle and these both are 45 degree. So 90, 45, 45. The three angles are like this. And this is the second set square which we have in our geometry box. This is 90 degree, this is 30 degree, and this is 60 degree. So 90, 30, 60, that is total is 180 degree, right? So these are the two types of set squares which will help us to understand various types of quadrilaterals. So first let us make a square. So we take two similar kind of set square, that is 45 degree set squares, okay, and we join them like this and we get a square. All sides equal, all angles 90 degree, like your maths teacher's expectations. Perfect. Now let us make a rectangle. So we take this 30, 60, 90, two set of the same set squares, and we arrange it like this, right? So what happens over here, this 30, 60 together becomes 90. Here also 30, 60 together becomes 90. Already these two are 90 degree angles. Now opposite sides are equal, right? So a rectangle, angles are still 90 degree, but sides are not equal. All sides are not equal. Only the opposite sides are equal. Now let us make a parallelogram. So we take 90, 45, 45, two similar type of set square, and we arrange them like this, okay, and you get a parallelogram. You can see the opposite sides of a parallelogram are parallel. These two are parallel to each other, these two are parallel to each other, so it's a parallelogram. It's opposite sides and opposite angles are also equal in this case. Now let us make a kite. You need 90, 30, 60, two set of this set squares, and we arrange them like this, okay, so you get a kite. You can see these two adjacent sides are equal. Here also adjacent sides are equal. You can see the diagonal here, which will be like perpendicular if you draw another diagonal over here from this two vertices, okay. So diagonal will bisect one of the diagonal, not both the diagonals. Let us make a rhombus. We are using the 30, 60, 90 set square. We need 4 of them. So we need to arrange like this side by side, and we make a rhombus, right? You can see it is looking like a tilted square. A tilted square is on an adventure, right? It becomes a rhombus. But the sides are still equal. So here in a rhombus, the sides are equal, but the angles are not equal, right? All the angles are not 90 degree, you can see. Okay, only opposite angles are equal. And you can see here, you can imagine the diagonals. They are perpendicular bisector. Perpendicular bisector, you can see a perpendicular line, 90 degree, 90 degree. In this, it is very clearly visible. And you can see it is bisecting, means it is dividing into two equal parts. If you see here, this also is being divided into two equal parts. So in a rhombus, all the sides are equal. Angles are not 90 degree. It is a tilted square. And the diagonals, they bisect each other at right angles. That is, they are perpendicular bisectors, right? Now we form a trapezium for which we need 4 set of the same, that is 30, 60, 90 set squares. So first in the center we join them like this, okay, and one you arrange from here, the other you arrange from here, right, from both the sides. So now you get a trapezium. You can see only one pair of opposite side is parallel. These two are parallel to each other. These two are not parallel, right? So the important property of trapezium is only one pair of parallel sides, okay? Just like when only one friend supports your weird ideas. right? So that's a trapezium. And that's how your set squares can shape the world of quadrilaterals. Math isn't just about numbers, it's about angles, adventure, and creativity.